Today's lesson is about recognizing and using the common types of reactions that happen in chemistry. There are 6 main patterns when you're doing chemical reactions. They all depend on how many chemicals are you mixing together and how many chemicals you get made, and how each element gets rearranged in terms of its partnership. Let's have a look at the 6 common patterns. Pattern number 1 is called a synthesis reaction. And here is a general equation showing what happens. We're just using random capital letters here. These do not stand for elements in particular. If you have 2 elements reacted together and they get stuck together and form one compound, that's what's known as a synthesis reaction. So the description or definition of a synthesis is you get 2 chemicals becoming one. The opposite to a synthesis reaction is called a decomposition. When you have one chemical breaking apart into 2 separate products, that's what's called a decomp. Your elements get separated from each other, and that's shown in the balanced chemical equation by using a plus sign between them. The third type of reaction is called a single displacement reaction. And it follows this general pattern. Usually you see a metal element that's by itself attacking a compound. And what happens is that element doesn't want to be alone anymore, so it's going to steal the other metal's partner. So the A is going to go with the X, and you get AX made as a product, and then that kicks the B out all by itself. This is called a single displacement reaction because only one element is stealing a partner. You only have an element by itself, so it's single. Kind of an everyday analogy of this pattern is a bodybuilder stealing a nerd's girlfriend, or someone cutting in on a couple that's dancing. The next pattern is called a double displacement pattern, and that's where you have 2 metals with partners to begin with, and what they do is they switch their partners during the course of the reaction. To see this pattern, I usually say the first goes with the last and the third goes with the second. That's why the A, the first thing, is going to go with the Y, the last thing, to make AY. And then the B goes with the X, the third goes with the second, to make your second product BX. The reason why we say the third goes with the second instead of the second going with the third is we have this rule in chemistry that if it's a metal, it's always written first in the formula. So if you go XB instead of writing it as BX, it's like spelling a word wrong in English class. You don't want to do that when you're writing. The 5th type of reaction is called a complete combustion reaction. It's when we take a chemical and we burn it with lots of extra oxygen mixed in. You see this as a blue flame or sometimes as a white flame. And it's called a complete combustion reaction because all of your fuel is burned, which also gives you the maximum amount of heat given off from your reaction. You recognize them because they follow this general pattern. This X here is your fuel, and it's any chemical that has carbon and hydrogens in it. So you take something with C's and H's, and you add oxygen gas to it. And if it's a complete combustion, you are only going to see CO2 and H2O come out as your products. The only thing that can change in a complete combustion is what you're burning, the CH fuel that you're going to start with. As human beings, when we do combustion reactions and do burn things, we want to try and make them as complete combustions as possible. So we have all kinds of fancy devices to try and do that with. So like in a car engine, we've got your carburetor coming in that mixes your fuel in your oxygen so that there's extra oxygen mixed in so that you get a complete combustion reaction. That's, of course, if your engine's working right. If you don't have enough oxygen mixed with your fuel, then you get what's called an incomplete combustion reaction. You still have that chemical burning with oxygen, but you have too much fuel or you have too little oxygen in your mixture. You can tell this right away by looking at your flame. You get this orange or yellow flame, and it's described as being a dirty flame because you often get soot or ash or smoke coming out of your reaction at the same time. This will clog your machinery if you're doing this kind of combustion in an engine or in a furnace. Because there's not enough oxygen mixed in, then not all of the carbon in your fuel gets changed into carbon dioxide. All of the hydrogen in your fuel will turn into water, and some of your carbon will turn into CO2. But as you start running out of oxygen, there's not two oxygens that can go with your carbon, but there might be one, so you can start making some carbon monoxide. This molecule here, carbon monoxide, is really dangerous. It is a clear, colorless, odorless gas. And it's actually very poisonous. And if you do an incomplete combustion, you're not going to know that you're creating this unless you have a CO detector. Because now we use gas in combustion reactions in our furnaces and in our stoves and other appliances in our house, we have this regulation that we have to have a carbon monoxide detector in our home. Because if one of these appliances doesn't do a complete combustion and starts burning incomplete because it's malfunctioning, you can have a buildup of CO in your house that could potentially kill you. So your detector would sound an alarm, and whenever you hear that, you have to leave your house immediately and call the fire department. So this is the difference between a complete and an incomplete combustion. It all has to do with how much oxygen are you mixing in with your fuel. If you have enough oxygen or extra oxygen in, then you're just going to make CO2 and water. If you don't have enough oxygen, then not all of your carbon is going to turn into CO2. When you start running out, you'll get some CO, and then when you really run out and you don't have any oxygen left, you get some solid carbon left over. And that's the soot, ash, or smoke that gets created. So these are the 6 most common types of chemical reactions. There are chemical reactions out there that don't fit these 6 patterns, but most of the chemical reactions that we do in everyday life will either be a synthesis, a decomp, a single displacement, a double displacement, or some kind of combustion. And like we talked about as humans, we try as best we can to make them complete. Now that we know what the 6 patterns are, we can do a couple of things. We can look at chemical reactions and then look at the pattern and see which one fits to identify the type of reaction that was done. Also, what we can do too is if we now know the pattern, if we know what chemicals get mixed together, we can predict what chemicals will be made by following the pattern. We'll talk more about that later. So let's look at some reactions and identify what type of reaction happened. For example 1, we'll talk about thermite welding. Have you ever wondered how you weld railway tracks together in the middle of the bush? They do this chemical reaction to connect your 2 metal rails. If you take aluminum and react it with iron oxide, you get aluminum oxide and iron out. Look at your note and look at the patterns to see what type of reaction this one is. When looking at real-life chemical reactions, it helps to identify individual elements by looking for capital letters. Whenever you have a capital letter, that's the start of a new element symbol. So if you see here, I have a capital letter, that is one element, and then here I have two capital letters put together. So this is a compound when you have two elements attached together. Same thing over here on this side. I got two capital letters, the A and the O. That gives me two elements, so this is a compound. And then because I only have one capital letter here, I just have one element. So on your types of reactions note, look for a pattern where you have one element plus two elements gives you two elements plus one. Pause the video here until you have your answer. Let's take this up. First, let's look and see what the elements are doing. You notice here I have an element by itself, aluminum, and it's reacting with a compound because it's made up of two different elements. You notice that the aluminum is going to steal the oxygen and become aluminum oxide. Over here is the product. And that's going to kick the iron out all by itself. To simplify this, if we get rid of the specific elements and we write down the pattern using just letters of the alphabet, I would have an element by itself, and here I've got two elements together. And then over here, the element that's by itself is going to steal the partner. Hey, that's the definition of a single displacement reaction. Go back to your types of reactions note and write down this equation as your example of a single displacement reaction. Pause the video here until you've done that. When you leave iron outside in the rain, very common reaction is that it rusts. Have a look at the pattern and figure out what type of reaction this is. Here you have one element by itself plus another element by itself being squished together into a compound. Whenever you have two chemicals forming one, this is known as a synthesis reaction. Go back to your types of reaction note and write this equation as your example of a synthesis. A lot of people in Dufferin County have one of these in their basement. This is a water softener. Because of the kind of rock that our area is built on, we have a lot of calcium and magnesium compounds dissolved in our water. And that can be a problem when you start heating your water up. When you do, then you can make calcium carbonate or magnesium carbonate solids, which is your lime scale. If you think about what's inside your kettle, we often in this area have this white, chalky, hard substance that coats the inside of our kettle, well, that's our calcium and our magnesium carbonate coming out of the water. What a water softener does is this reaction to remove the calcium carbonate from the water and stops our appliances from getting junked up by the lime. Have a look at this reaction and figure out what type is it. Here I have 2 elements plus another 2 elements. And whenever you have 2 sets of compounds reacting together, you typically have a double displacement reaction. Let's see if the pattern works. Does the first go with the last? Hey, over here I have Na going with my CO3. And does the third go with the second? Hey, over here I have the calcium going with the chloride. So this is an example of a double displacement reaction. Pause the video here and write this equation as your example for a double displacement on your note. Here's the next everyday example, when bubbles form in a pop solution. Look at your note and see what type of reaction this is. You notice here, I have one chemical. There's no plus sign on this side of the arrow. So this is all one thing. And then it falls apart into 2 different things. That's the pattern of a decomposition reaction. Go back to your types of reactions note and copy down this equation as your example of a decomp. Here's the equation for the reaction that happens in your furnace. Look at the patterns and figure out what type this is. Notice in our picture here, we have a blue flame. This helps us figure out that this is a complete combustion reaction. I have a fuel, something with C's and H's. I'm adding oxygen to it, and the only thing I'm making is carbon dioxide and water. Write this reaction as your example of a complete combustion. This next equation represents a candle burning. What type of reaction is this? Notice the yellow-orange flame. This is showing an incomplete combustion. I have a fuel, something with C's and H's in it. I'm adding oxygen, and I'm not just making CO2 and water. I have some CO and some C by itself also formed. That's because there's not enough oxygen in the air by itself to totally take all of the carbon from the fuel and change it all into CO2. When you start running out, you get some CO, and when you completely run out of oxygen, you get some solid C made. On your types of reactions note, copy this equation down as your example of an incomplete combustion. Let's try some more out. Which type of reactions are each of the following? Pause the video here and classify these reactions. Here are the answers. For A, I have one chemical falling apart into two different products. That's a decomposition. Instead of writing the whole word decomposition, you can short form it by using a capital D. Here I have two elements plus two elements. And if you look at the pattern, the first goes with the last to make my SiF4, and the third goes with the second to make my H2O. This is a double displacement reaction. A short form for that is writing it as DD. For the next one, I have one chemical plus another, and I only have one product. So two things become one. That's the definition of a synthesis, or capital S for short. And finally, for D, I have a metal by itself stealing a partner. The copper is going to go with the chlorine, and that kicks the hydrogen out by itself. This is the definition of a single displacement reaction, or SD for short. Now try out the questions on the reaction types worksheet. For part A, identify these reactions as being a synthesis, a decomp, a single, a double, a complete combustion, or an incomplete combustion. For part B, we are going to start predicting the products of reactions by completing the pattern. For example, if you look at this first one here, I have two elements plus two elements. Hey, that's probably going to be a double displacement reaction. So to predict the products, I'm going to follow the pattern. The first goes with the last. So my AG is going to go with BR. Down here in the box, I'm going to look for that product. There it is right there, AGBR. So I can copy it down from the box. Also, for a double displacement pattern, the third thing, the Zn, goes with the second thing, the F. So I'm going to look in my box and look for those two elements together and copy down the products. Try the rest of these questions out as well.